Algebra 1, Lesson 6.2, Solving Systems by Substitution. Okay, so let's take a look at the steps that are listed here for solving systems of equations by substitution. In some cases, we may use all 5 steps. In other cases, we may only have to use a couple of them. Step 1, as you can see, is that we want to make sure that we solve one variable in at least one equation, if necessary. So this means that if we're in a situation where we don't have y equals or x equals as one of our equations, then we need to solve for that in order to get one of the variables by itself. Step 2 then tells us that we're going to take that information and substitute the resulting expression into another equation. So if we solve for x or we solve for y, we're going to take that information and go ahead and plug it into the other equation in order to solve, which is step 3. Once we've plugged our values in or substituted our values in, we are going to solve the equation to get the value of the first variable. Step 4 is once we have that variable, we're going to take the value that we solved for and plug it into our original equation, and then we are going to solve that to get the other variable, which will then give us our x, y, or ordered pair. We can plug those in and check, and this is really important, is that we check it. Let's take a look at an example here. Okay, let's take a look at the first example here. So y equals 3x and 2x plus y equals 10. And right away we can see that we already have one of the variables solved for. Here we have y equals, so we're going to take this value, 3x, and we're going to substitute it in for y. So when I rewrite it, I'm going to end up with 2x plus 3x equals 10. Now I'm going to combine my like terms. 2x plus 3x equals 5x equals 10. And then I'm going to solve for x by dividing both sides by 5. And I get x equals 2. So that's the first part. Now I'm going to take that information and my x equals 2, I'm going to substitute back into where I started. So y equals 3x is now going to become y equals 3 times 2. Y equals 3 times 2 equals 6. So my coordinates are going to be 2, 6, and there's my ordered pair that makes the statement true, and I can check my work by plugging those values in. I can say y equals 6, and if x equals 2, then 6 equals 3 times 2, which is 6, so that's true. And I can plug it into the other one and say 2 times 2 plus 6 should equal 10. So 4 plus 6 equals 10, so 10 equals 10, so that is also true. So it checks out. And so by using substitution, taking the value for y and substituting it into my place of y in my second equation, I am able to solve and then take that information and plug it back in. And so I can take the information and identify my ordered pair, x and y, that makes the statement true. Let's take a look at another example here. Let's go with y equals 6x and y also equals 4x plus 18. Now in this case we're saying y equals 6x and y equals 4x plus 18. So really what we can do is rewrite this. We're going to substitute 6x here into the position of y in the second equation. So I'm going to get 6x equals 4x plus 18. Now I'm going to solve for x, and this goes back to some things we've learned in the past when we have the variable on both sides. we want to get the variable on the same side first of all, and end up with 2x equals 18. Now we can solve for x, dividing both sides by 2, and get x equals 9. So we have our first part of the ordered pair, and now we have to take what we've learned from x equals 9 and plug it back in to solve for y. So y equals 6x. So y is going to equal 6 times 9, and 6 times 9 equals 54. So our ordered pair, or the solution that's going to make these two equations true, is going to be 9 for x and 54 for y. And again, we could take our information in and plug it in to solve or to check our answers. We can start with the first one. 54 should equal 6 times our value for x, which was 9, and 54 does equal 54, so that checks. And then we can do it on the second equation just to double check. 4 times 9 plus 18, so we're going to get 36 plus 18, which equals 54. So again, it checks out. So by substituting our first value in, we're able to solve for x, which is what we did first. Then we substituted that value in, solved for y, which is what we did second. And that gives us our solution to this ordered pair. We can take a look at one more example. Let's do one where we have to do a little work here. Let's take 3x minus y equals 5, and we're going to have negative x plus 2y equals 0. So we have to choose what we want to solve for first, and then I'm going to pick, in this case, I'm going to solve for x in the second one. I'm going to go ahead and say negative x plus 2y equals 0. I'm going to subtract 2y from each side, and I'm going to be left with the opposite of x, or negative x minus 2y. And then I'm going to go ahead and divide by negative 1 and get x equals 2y. So I got rid of that negative symbol in front because this is the same as saying negative 1 right here. So those cancel out. Negative divided by negative gives me a positive. So x equals 2y, I can substitute that into my first one. So 3 times x, which is going to be 2y we said, minus y equals 5. And I'm going to go ahead and use the distributive property. 6y minus y equals 5. 6y minus 1y is basically what we're saying here. So we get 5y equals 5. Divide both sides by 5. And we get y equals 1. So now I can take that and plug it in and say the opposite of x plus 2 times 1 equals 0, which is our second equation here. So the opposite of x plus 2 equals 0. I'm going to subtract 2 from each side. Opposite of x equals negative 2. And again, I can divide by negative 1 and find out x equals 2. So my coordinate is 2 for x, 1 for y. Ordered pair. And again, I can substitute that back in. I'll do it real quick here. 3 times 2 minus 1 should equal 5. So we get 6 minus 1, which equals 5. 5, so it checks. So our solution is going to be 2, 1. So there's some examples. Why don't you give it a shot now on your note-taking sheet.